Okay, team, the next part of this, and we started this on Monday, where we're looking at the orthocenter, the in-center, centroid, and the circumcenter. And your job is to go find out what they are. Part of the reason I'm having you do that is to practice reading about geometry and understanding the definitions and be able to talk about it with your students. And then we're going to talk about points of concurrency, where these meet, and does it happen all the time? So I want to go to GeoGebra, and I'm going to make the centroid. And as you can see right here, the centroid is where the medians of a triangle meet, and the medians are the is where the from the vertex to the midpoint of the opposite side. So there's one. Let's do some more midpoints here. Let's do a midpoint for this one. Let's do a midpoint for that one. Let's get our segment tool out. Let's go from this vertex to the midpoint of the opposite side. This vertex, the midpoint of the opposite side. So from where it goes from the vertex to the midpoint, those are called medians. And I get my pen. So B, D, N, and make sure that's an N. And there's one right there. And there's my really funky arrow. And then our job is to figure out, is this point right here where they intersect, does it always stay inside the triangle? So maybe I'm going to drag it around. Oh, look, there's a median right there. We could do that. There's a median there. There's a median there. Ooh. As we're dragging it, it looks like where these three medians intersect is in fact inside the triangle. Okay, so I'm going to want you to do similar things for the orthocenter, the in-center, and the circumcenter. Where does the point of intersection lie in the triangle? And I'm going to show you one way to prove that three lines are concurrent. And I think we're going to do the centroid again. But I just wanted you to, your job is to fiddle with this first. This is where you explore. You practice exploring so that you can help your students practice exploring, okay? All right, cool beans.